Thanks for coming. I'm Serj. I work at Piconic. Hopefully next year when I say it, you'll think, oh, the company that handles all mobile payments in Europe. And today, I want to go with you on a small trip. So we're going to take a very simple task and try to implement it with these two solutions. One is Room, and the other one is SQL Delight from Square. First of all, why? Why should you care? If you think of any, so I exclude the question with persistence, so we assume you, in some case, need it, right? So if you think of any other object mapping library, let's say Realm or something in that domain, these libraries come with certain caveats. So one of them is, usually your database is kind of a black box. For example, it's usually with Realm, if you take that for example, it relies on a lot of native code. Of course, you can go and dig into it, but at the same time, you lack the certain tooling that you usually have when you use an SQL or SQLite library. It's not that flexible, so some libraries try to implement proper APIs to kind of match the power of SQL, but in most cases they lack, either they overcomplicate things. For example, if you just need to calculate how many rows you have, you still have to query the entire objects and count the numbers in the list or things like that. So it's usually comes with a bit of an overhead. Also, some of them use reflection, and there's also a very huge runtime component. Again, coming back to the example with Realm, I'm not saying it's a bad library, it's just if you use Realm, you add a native component which weighs about 1 megabyte, and you have to support it for at least 4 CPU architectures. So that means your app grows by 4 megabytes just because you're adding Realm as a dependency. So for some people it could be a problem, for some people not, but that's another story. Another thing I didn't add, but actually had a discussion today, Realm has very big problems with threading. Like if you ever tried creating like Realm in one thread and then accessing it from another thread, you would always run into problems. So there are some tricks and pitfalls you have to be aware of at least. So let's assume we don't want this solution. We want something very simple. We're running everything on mobile. So in the end, Java is fast enough for us. And SQL in the end is also kind of native. So why Room or SQLDelight? Both rely on code generation. So there's a very small amount of reflection, almost non-existent. They provide a pretty much healthy level of type safety. And you get the power of SQL without the boilerplate. I left here like an asterisk because it depends on the library, and we're going to see that in a couple of moments. So here's a very simple solution. Most probably everyone tried to do something like this. I have a JSON, and for some reason I want to save it in the database for offline storage or wherever. This is like a normal response from GitHub. Of course, I removed a lot of fields just for the sake of simplicity. We don't want to build huge objects with 20 plus something fields. And if we analyze this, we see like quite a pattern. So we have an object with 3 fields, that's name, description, and owner, where owner is an object of itself with another 2 fields. So that's easy to map in Java. Like when you see something like this, something like I'm using auto value here. Sorry, my code is not fun. And you kind of imagine something like this. So you have an object, I missed the name, and another one to match the user. So in the end, you care about these few fields. The other thing is just noise in this certain example. So what we're gonna do, I'm gonna assume that the objects that we're gonna access in memory are these auto-value objects, and the other ones that we store in the database will be different types. So we'll just assume that there's a certain mapping here between the database objects and so on, so I don't have to write also like the JSON code and try to do certain parsings again. Let's try to do this with room. How would you do that? It's pretty simple. First, you need to declare a record object, right, or an entity. In this case, I called it room repository. You have a name, description, owner, the same. And the first thing you have to do is, of course, declare that this is an entity, right? It has a table, and this is pretty easy. I assume that the name of the repository is unique. GitHub actually doesn't allow you to create on your namespace 2 repos with the same name, so I'll use this as a primary key. And it's not null to ensure that the compiler will actually protect me from failing. Like if I try to include the null value there, it will actually fail. And regarding the user object, or the owner field in this case, there's a very interesting trick that you can do with room just to make things simple and fast. You can say that this object or field is embedded. And what this does, actually, it allows you to declare the user object without any record. So if you look at the user object code, it has no entity annotation. It's not tied to room anyhow. So it doesn't even, room doesn't even need to know about it. And what's happening under the hood is, like, if you think of it in normal relationship, in normal database development, you would create 2 tables, one for the repository, one for the user. But when you annotate it with embedded, you're actually transforming it into something like this. So room, under the hood, the code that will actually read the record will read the user object from the same row, from the same table, and then just store it in a Java object separately. So it's good if you have like very simple objects and you don't care about the speed that much. For example, if it's just like, I don't know, 1,000 records and each will have an embedded value, it shouldn't break anything. But if you go like start scaling this, of course, you should think of a normal mapping. But for the sake of simplicity, let's say we will go this path. Just to avoid like any extra steps. So we have our records. This is like pretty plain and simple. And this will actually account for a table in our database. Now we need to somehow read that record, right? So in this case, what you would do, you would create an interface. I called it service. You could call it whatever you want. And the contract just requires you to annotate the interface or the abstract class with DAO, which tells room that this is a provider object that will do the queries actually. And the method with something that, with an annotation called query, and put the SQL query inside. Actually, in IntelliJ IDEA or Android Studio, this will be highlighted. So instead of a green text, you'll actually see select as a keyword, from is also as a keyword. So you'll actually get some, if you start writing more complex queries, you'll actually be able to distinguish them from one another. It won't be just plain text. So kudos to the guys who did it. But yeah, if you used retrofit ever, this is kind of how it looks like. But then you need a database object. So you actually have to declare that there's a database object that provides this room service, this DAO object. And for that, you need to extend from the room database class that's required by the documentation, and also has to be abstract, because this code will be generated. You don't have to actually write anything. It will be just generated for you. And all you have to do is annotate it with database, and show what kind of tables should be in that database. So in this case, since we're only using the repository table, we'll have to declare that, and version, we start with 1, right? So nothing, this is something fresh from the start. Creating that database is pretty much simple. Like after that, at this point, you're done. All you need to do is call a database builder, pass the application context, pass the class, and the file name. And as soon as you call build, you have an instance of my database which will use the generated code that was generated through compile time. And you can, from there, you can access the service and call that interface method repositories and subscribe to it and wait for a response. If you're testing, which that is something I really like about Room, all you have to do is create an in-memory database. What this will do, it will completely avoid the I/O stuff, so there'll be no disk writing, and you'll just have an in-memory instance of the database, so basically like a lookup table. And if you're writing espresso test, this is something I kind of failed once. You have to specify that queries on the mainframe should be allowed, because otherwise the thread of the test will be treated as the main thread, and Room actually does some checks that where you're actually calling it. So this is pretty much simple. Any questions so far? Nope. Yeah. We can actually go further. One thing that Room allows you to do is also simplify migrations. If you ever wrote like a SQL Open Helper class, you remember there are like 2 methods. One is on create and the other one on upgrade, and you always have to like look up what is the new version, what is the old, and you kind of get all these switch cases eventually. Like after 10 or 16 version updates, it kind of becomes cumbersome. Room actually simplifies this. You can use a migration object, and where you just specify the version from which to which you upgrade. This, it doesn't necessarily has to be from 1 to like incremental, so you can always write a migration from 1 to 4, and then, sorry, inside you can just do your operations if you're pretty much sure that there's no breaking change that will actually crash your application from the database update. So you can play around with this. And normally you would actually store this migration object in a private static field. So it would look something like this. And you can add as many as you want. So you can just follow a pattern that, okay, I'll have migration from 1 to 2, from 2 to 3, from 3 to 4, and so on. Or you can have just one migration object from 1 till the last one, which, I don't know, 16, 21, 42. Whatever is your version. So it's pretty much simple. We spent like less than 15 minutes, and we have code that actually will run and will give us, will query the database. It will be thread safe. You can also, you saw that we used a single, so you can use RxJava. All you have to do is add a dependency. So it's pretty much simple. Let's try to do the same with SQLDelight. Here we'll have to move a little bit to a different realm, because SQLDelight allows you to declare everything in SQL. So the plugin allows you to create a folder. It will be called SQLDelight, and in a certain package name, we would create something like a repository SQ file where we would start creating the table. And here is like normal SQL creation, so having the fields like the name, which we declare as a primary key, the description, and as you see the owner here, I notice the text, and because SQLDelight doesn't have this flattening out of the box, so what you actually have to create 2 tables. So here what I would do, I would say that owner, in my case, is a foreign key, which relates to the user table and its login. So what this syntax actually says is that the owner non-null key is actually the login field in the user table. So I assume it will be unique. And creating a user table would be pretty much simple. I set the login as a primary key, so I know it's unique. And selecting from it, it's pretty much easy. The syntax here, as you see, like select user two dots, this is actually declaring the query, and SQLDelight will use that to generate the code for us eventually. We'll see it in further slides. I can do the same for repositories. So this is like the selection, and as you see here, I have to do a join. So I actually have to query two databases and do a little bit of extra work to query my list of repositories. The code that is generated from this looks kind of like this. I hope you can read it. Yeah, actually, yes, from this screen, not from here. But yeah, this is actually a lot of generated code. These are queries, the table creation. Let's assume we don't care about it. Let's just move on, right? And what you would actually do, again, I'm using auto value. The object that is created for the repository is called a repository model, so it will use the name of the file and append model, and you'll find it on the same package as you left it. And basically, that's it. So this is what I need to do. There's one extra step. Of course, I have to create a similar mirror image of the user model, and I need to add a factory and a mapper. What a factory is actually the object we will be using to perform the queries, and the mapper is another object that allows us to map the cursor that we read from the database open helper to the actual object. So this is just boilerplate that you need to write at the moment with version 0.6. Unfortunately, you'll have to create a database open helper. Like here, there's no getting away from it. So of course, you have the onCreate and the upgrade methods. But pretty much, it's quite simple. All you do is call the generate code will actually create the fields for the create table. So you don't have to write that. You wrote it in one place in that SQ file, and that's it. So here you just reference it as a final static field. And querying it is actually quite fun. Unfortunately, SQLDelight is just one piece of the puzzle. If you want to use it with RxJava, you have to use a second library, which is called SQLBribe. It's also developed by Square. And what it does, it's actually an abstraction on top of the database classes of Android, which wraps it into observables that you can subscribe to and listen to database updates. So for that, we'll have to create an SQLBright object, and from there, we're using the database open helper that we declared previously, wrapping it with SQLBright and receiving something that they call a Bright database. So what this will do, it will use the Android APIs to provide you the query APIs to which you can actually subscribe. So this is like the machinery that they wrote so you can use perform queries using RxJava. I'm adding the IO scheduler to just make sure that all the database calls are called on the IO thread and not on the main thread. So as soon as you, this is, I don't remember, but I think this is actually a required field, so you have to pass a scheduler. But don't quote me on this. I was always writing like this, so I'm not 100% sure. And here, we're coming back to our SQLDelight repository object, and the factory that we declared. And as you see, we can call something which is called selectAll. If we come back a little bit to this, selectAll is actually the query we created to get the list of repositories that are stored in our local database. So this is what was called an SQLite Delight statement. What it actually does, it's just wrapping object that has the table names which will be queried, and also the actual queries that the Android SQL code understands. From here, it's pretty much straightforward. You just call create query, you pass in the tables and the statement, and use the mapper to match the cursor that you get from the database to a real life object. So in the end, the APIs, we can actually create an interface that would be repositories and which would return an observable to a database, and we can create a project where one flavor would use SQLDelight, the other would use Room, and they would work the same. So in the end, we did two exact same things. How do you feel about it? Like, what is your opinion already? Yeah, that's a good one. That's a good one. But in a nutshell, after all this, you would probably say something, yeah, Room is easy and simple, right? It's very well documented, by the way. You have, since Google I/O, you have like 100 plus 500 posts popping up every day. Like, there were like 7 steps to Room. That's what was by Florina herself. She works at Google, but from other people from the community, like, so Get a Room was available, so I took it as a name. It's quite easy to migrate, so it's actually, it's no different if you would migrate with the normal SQL Open Helper, but the only difference it allows, the API allows you to quantify these things. So you're actually creating a mental model of these upgrades, so which gives you kind of like a more structure instead of creating a mess with one switch case statement that goes through the entire database. I saw those, I don't know if you did. And yeah, Room supports the basic CRUD. Like, you wouldn't get that from my example, but overall, if you check through the documentation, you'll see that the normal read, update, and so on are supported. And it works with Kotlin, actually. I didn't put any Kotlin code here, but that was because of SQLDelight. And from my example, you would say, okay, the setup is cumbersome, it's too much stuff to write, and it's still in development. The current version is 0.6.1. It doesn't simplify your migration, or it doesn't quantify your migration, so you're kind of stuck in the same realm as you were. And it can be used only without a value. So Kotlin data classes are not supported, and you're kind of stuck there, right? So I think, so your opinion would be after this that, yes, let's go with Room, and let's drop SQLDelight. But now, the question would be, what is the complexity of your project? Because Room, with its simplicity, doesn't actually support things like views, indexes, and triggers. So if you go very deep into real optimization of your database queries, Room actually will not allow to do that, at least at this point in time with version 1. So what happens is that when you do a query, it will do it the normal way without doing any step-by-step optimizations. So if you're, for example, joining 3 tables and you're using a normalized database, then you actually will get some lack of performance there as soon as your data becomes more complex than just 1 table. Well, okay, one, it's quite a strong, but I would say in a realm of when you have more than 1,000 records and more than 5 tables. So as soon as you get very complex queries, you either have to migrate this to Java, so actually write additional filtering and querying on the Java side, or you will be kind of stuck with, yeah, basically you will be stuck there. It doesn't work with auto value, so you have to actually create either a normal Java object, and if you want the hash code, toString, and equals implementations, you'll have to write them by hand, or use the IDE to generate those for you, but then hope that each time you add a new field, you don't forget to update those methods as well. Or you can also, and the tooling is actually very limited. So if you update your queries in the query function, where you actually call it in the DAO, it will not, there's no proper way to actually go to the file of the actual record and update it. So as soon as you start refactoring, as soon as your database passed that initial bootstrapping phase that, okay, I created the first version, the second, the third, and you start updating and growing your data, instead of editing 1 or 2 files, you'll be editing kind of quite a few. On the other hand, SQLDelight has awesome tooling, so search and replace works, refactoring of ID in IntelliJ IDEA works, and as soon as you overwrite 1 file in the SQL, because that's the only part you actually have to touch, the same thing changes in the generated classes and propagates throughout your code. So in 99% of cases, when you refactor or update your database, you'll actually be editing only 1 file. And there is Kotlin support, at least rumors say there'll be Kotlin support in version 1. And as a nutshell, like I mentioned views, indexes, and triggers. SQLDelight actually supports the full stack of SQL. So if you want to create very complex joins or very like narrow views of your tables or some, I don't know, triggered slices and so on, you can actually do that in SQLDelight. I don't know any proper mobile example at the moment, to be honest, but if you're in a position where your data that you store on your local device is very complex, SQLDelight will actually simplify and give you some extra optimizations for that code, for those queries, where Room will just give you a nice looking interface. So I try to be here. The reason I'm saying this is not because I want to trash Room or I want to promote SQLDelight. I actually want to bring you to a balance that both libraries have a place to live, and in case when you're prototyping, when you're, I don't know, developing a very simple object where you have to store 100 records or something in the local database, Room will be your answer to everything. It has great support, it's developed by Google, it will be maintained, it has a proper abstraction layer, and you can do it in less than 15 minutes. You can set up the full infrastructure and just work. But as soon as you get out of these 99% of cases, I would urge you to at least consider thinking about SQLDelight. Thank you. Any questions?
Hi, actually I have a couple of questions, but I will probably come after to you. First one would be, why do you say there's no support for triggers and for indexes with SQLDelight? Because for indexes, for sure, you can even annotate it, and you can basically execute any statement. So I
With
didn't
SQLite, there
try.
is.
I didn't try with a trigger, but I don't understand why it would not work if you can execute basically any SQL statement with room. I
With
mean,
room,
yeah, yeah.
you cannot execute any SQL statement. You'll actually get some generation errors with like a message that it's not implemented.
Okay, so I could.
You will run on. I'm not sure. So about indexing, it's depends what you're thinking about when you say about indexing. Like so, because you can actually when I say indexing, you can actually create pre-queries, like index certain values in your tables and only then execute a query to the database. So it's like an extra step of SQL meta code before you're actually executing the query, which will give you that extra optimization. And I actually looked it up. I heard it in another talk. I had the same question. I was looking it up in the room documentation and trying to do that, and I didn't find any, at least at the current state, I didn't find. Maybe it's already in development and was gonna drop with the next version, but I didn't find it. So, and I tried to even like find a documented way how to do that, and I couldn't. So my assumption was that it's not. If you find a way that it's support, please drop me a line and just send me the code how to do it. I'll test it immediately.
For indexes, you would just, where you create your entity class and where you have the table name, then you have another property, indexes, and you can define what type of indexes.
But that's when you're mapping indexes between the tables, when you're actually referencing another entity inside your table, right? So this is, you're talking about the functionality when you want to have a normalized database when you have multiple tables. And then you actually use the indexes. This is like emulating the join. When you say, okay, my field, for example, is owner is a string and it's like it's the user ID, or an integer, and that is indexed to the, so the parent index would be the user ID in the room user object. So that's actually the join mapping. That's how they implement the join mapping, as far as their documentation goes.
Thank you, and I have another question, if that's okay. Have you tried implementing without auto-value the solution with SQLDelight?
Yeah, I actually had like a full Kotlin project. So actually from where this talk comes in, I had to make in 3 days a prototype. And I started writing in Kotlin, and then I needed like a offline solution, like to store some data. And I actually jumped in on SQLDelight, and I was using Kotlin classes and so on, and suddenly it just broke down. So it doesn't work. There's actually a branch in SQLDelight. It's called something like Making Kotlin or something like that. They're actually adding support for Kotlin data classes. But I don't know. The repo is fairly active, but it's kind of silent at the moment. So I don't know when that's gonna come in. So what I end up doing, I was actually created an abstract Kotlin class and annotated with auto-value, and just used the generated code, because in the end it's still Java code. Like it looked ugly, but it worked. But the next day I just figured that it's like there was too much machinery there, and I needed too much bootstrapping, and I switched to Room, because it was easy for the prototype. So for simple cases, I would say use Room.
Hi. Actually, it's not that calling SQLDelight doesn't support Kotlin is that, I mean, we are using SQLDelight in our project with Kotlin data classes. They work. Actually, the creator and the factory you have to implement is the same, but with less code because you can use Lambda, so you can just reference the constructor. But the only thing you have to do extra without auto-value is that you need to override your fields. So it's not like it doesn't work.
It's not like out of the box that you would just say it's a data class that implements a field and it works. Yeah. So you still have to write a lot of overvision, and the better solution would be to create an abstract class that, because in the end you're basically giving away these fields out, right? So something that had to be done by auto value in this case, you have to override it yourself manually, and then it drops the point of the data class, because in the end the data class is just writing the field once and not writing multiple overrides and so on. So it works with Kotlin because Kotlin is JVM. It just doesn't look nice, let's say so. Thank you.